Hello everyone. So today what we're going to do is we're going to put all of the transformations we've been seeing in the last few days all together and see what we can do with those. So as a quick little recap, I want to talk about each one of these transformation letters here and discuss and review what they do to the equation. So once again, the only three letters you have to worry about are the A, H, and K, because the X and Y are only there to link things to the equation. So, to the graph, sorry, from the equation to the graph. So X and Y are always in these formulas, but the A, H, and K are the three things that affect the graph itself. Now, A is actually the most complicated one because there's two different things you have to worry about with A. Is it negative or positive? And then the number value. Okay, so what happens if the A value is negative? It is a frown-shaped parabola. We call that a reflection. I'm just going to draw it as a picture. If it is positive, it's going to be a smile-shaped parabola. And that's all that the sign does. But then you actually have to look at the numerical value of A without the sign. And if the number value of A is greater than 1, then you have what we call a stretch on the parabola. If the A value, the number value itself, is between 0 and 1, then we have a compression on the parabola. And these are vertical stretches and compressions. There are actually horizontal stretches and compressions, but we don't see that in grade 11. Okay, so these are vertically stretched, so narrower. Actually, I'm going to write that down actually. Narrow and wide. So when you stretch the parabola vertically, it becomes narrower, and when you compress the parabola vertically, it becomes wider. For the H value is a horizontal translation. So if the sign in front of the H is a plus in the bracket, that means, and this is where things get tricky, it's the most difficult one to remember, it means move left when it's in the bracket. If the H value is negative, it means move right. For the K value, that's actually the easiest of them because it does exactly what we think it does. It'll move the parabola up or down. So if K is positive, it moves up. If K is negative, it moves down. And the H and K are very important in this equation. They are the reason that this is called the vertex form of a parabola. Because the vertex, remember that the vertex is either at the bottom of a smile shape or at the top of a frown shape. The coordinate of that point is going to be given by the H value and the K value. And this is the H value without the sign, or with the opposite sign, sorry, of what's in the bracket. So the same thing that happens here happens here. So if H was -3, and we're going to see this in an example in a minute, but if H was -3, it would be a +3 in the coordinate for the vertex. K matches whatever it is. But this is why it's called the vertex form, because you can very easily find the very highest point or the very lowest point on any parabola just by looking at the H and K in vertex form. So here's an example of a question you could be asked to do. Sketch this parabola. So the very first thing that I'd want students to do is tell me what the vertex is. So can you pull out the coordinate of the vertex? Well, this is our h value. It is a -4 in the bracket, but it actually means that it's a +4. Let me use color to highlight that. It actually means that it's a +4 inside of the vertex. The k value is over here, and it is the exact same value in the vertex. So if you know how coordinates work, this is the x value, this is the y value, I now have a pretty good idea that my parabola is at 4, 2, so 1, 2, 3, 4, 1, 2, so here's the vertex. And then I can look at the a value and say I also know that it's a smile shape. Now I don't know exactly what the, how narrow or how wide it is yet. We're going to actually need our table of values to know that. But I do know that this is the general shape of the parabola. All I needed to know was the vertex and whether or not the a value is positive or negative. Now I want it to be a little bit more precise than that. So I'm actually going to erase this. So let's use our table of values method. Hold on a second. Let's use our table of values method. To figure out what all the points on the parabola are going to be. So we have both an x transformation and a y transformation, and if you remember one of my previous lessons, I had said that if you have x transformations, you're going to want to leave some room right here. Okay? So what are our original x values that we always have been using? Well, recently we've been using -2, -1, 0, 1, and 2. Now in the next example, just a little bit of foreshadowing here, I'm actually going to reduce this because this is a lot of work when you know that the parabola is going to be symmetrical around the vertex anyway. So really all we need are the last 3 points, and then we need to draw our symmetry points on the other side. So I'll explain that soon, but just to get your brain thinking about it a little bit. But that'll be a lot less work if we only have to look at 3 points instead of 5. All right, now what are our normal y values? Our normal y values are 4, 1, 0, 1, and 4. So if you don't remember where that comes from, it comes from the general parabola, the easiest parabola I should say, which is y is equal to x squared, where you're just taking the x values and squaring them to get the y values. So what are we going to do to all of the x values? We are going to add 4 to all of them, because that's what the vertex is saying to do. So we're going to add 4, add 4, add 4, add 4, and add 4. So what are we going to do to all the y values? Well, the problem is there isn't just one y transformation. This is also a y transformation. The 3 is multiplying the bracket, and the +2 is adding to the bracket. And those are the two things we have to do to the y values. We have to multiply by 3, and we have to add 2. So we're going to do times 3 plus 2, times 3 plus 2, all the way down. And then we're just going to rewrite those points in our second table. So we have a nice clean table of points to plot. So what's -2 plus 4? It's 2. What's -1 plus 4? It's 3. And then we just go 4, 5, and 6, because we're going up by 1s originally anyway, so these are going to go up by 1s too. And if you don't believe me, just do all the additions and you'll see. Now for the y values, it's a little bit more math. So 4 times 3 is 12. 12 plus 2 is 14. 1 times 3 is 3. 3 plus 2 is 5. 0 times 3 is 0. 0 plus 2 is 2. And that's our vertex. Okay, so our new vertex is at 4, 2, matching what we had already written up here. The next one is 1 times 3, which is 3 plus 2 is 5. And you can see that we've got that symmetry happening around those 2 points, around the vertex, I mean. And then 4 times 3 plus 2, we know is going to give us 14 from the symmetry above here. Okay, so We're going to use that symmetry to our advantage in the next example, so we don't have to do quite as much work. Now it would just be a matter of plotting all those points, and I'm not going to do that here, folks, because it's kind of difficult to do on my smartboard. If what I would actually suggest is if you had Desmos, you could just plot those points in Desmos, or if you have graph paper, you could do it on graph paper. But you could easily now plot that parabola, and I've already shown what it looks like. The vertex is at 4, 2, and what the 3 value does is stretches it. So just to exaggerate things a little bit, we're just going to draw a very narrow parabola like this. I should probably put my X and Y here. Okay, so it's a very narrow smile-shaped parabola with a vertex at 4 and 2. So that's how you do it. All right, you identify your X transformations, you do those X transformations in the table using the opposite sign, as we had pointed out in the vertex, and then you do your 2 Y transformations. And I mean, some of the transformations can be missing sometimes, right? They don't all have to be there. I'm just showing you examples of when they all are there today. So let's look at this example. So we're going to try to speed things up a little bit now. Let's write our vertex first. So the H value here is +3. So what value will go in the bracket for our X value of the vertex? It's always the opposite sign of what it is in the bracket. Okay. Our K value is -1. That one stays the same. So we already know that on our parabola that my vertex is at -3, -1. Okay. We also know by looking at the A value, because it's negative, that this is going to be a reflected vertex. So it's going to go down, and it's going to be stretched again because of the -2. Okay, so it's still going to be narrow. So we already know all of that about the parabola, but we want it to be a little bit more perfect than that. So here's where we're going to start to simplify our life a little bit by doing some less calculations. Like I was saying in the previous example, because we know that our parabola is symmetrical around the vertex, let's just use 0. Oh, sorry, I'm going to need some room there. I better move that over. Let's just use 0, 1, and 2 as our 3 points. The -1 and -2 is just going to be symmetrical to those two. So as long as we know where the symmetry happens, and you'll see what I'm going to do to show you that in a second, okay? Then we're good to go. So then we got 0, 1, and 4 as our regular Y values. Remember, we're just squaring the X values to get our regular Y values. So now let's apply all of the transformations. So our vertex is -3, so we're going to subtract 3 to all of the X values. Now for our Y transformations, you can't just look at the coordinate of the vertex anymore, because the -2 is also participating in the Y transformations. So the -2 multiplies, and then the -1 subtracts. Okay. So let's do our table of values here. Okay, so what is our new coordinate going to be for the X values? So 0 minus 3, which is -3, 1 minus 3, which is -2, 2 minus 3, which is -1. Our Y values are 0 times -2, which is 0, minus 1, which is -1, 1 times -2, which is -2, minus 1, which is -3, 4 times -2, which is -8, -8 minus 1 is -9. Now for this one, I'm actually going to try to plot it because I'm doing something different. So I want to make sure you see this in case you're asked to do it. Now, because I know that my parabola is going to be down here from what I had shown you previously, I'm going to leave a little bit more room down here. So let's do -1, oh, wrong color, -1, -2, -3. Now I've got to go all the way to -9 in the y's, so I'm going to do -5 and -10, and that means we know just before that is -9. Okay? So let's plot our points. -3 and -1. I'm going to use blue for this, so -3 and -1 would be approximately here. -2 and -3 would be approximately here. -1 and -9 would be approximately here. Now here's where we're going to do something a little bit different that we haven't done yet. I want to put the axis of symmetry down on this parabola. So what the axis of symmetry is, it's a line that crosses through the vertex, which acts like our mirror. Because we only did 1/2 of the parabola, where does the other half go? Now I've gotten a lot of students that have mistakenly put it this way on the parabola. But our axis of symmetry goes through the vertex, and our vertex, in this case, actually let me go back to my pen here. Our vertex is this point here. We started with the vertex in this case. Okay, so let me just be clear on this. We go back to our previous slide. The vertex was in the middle, right? So our symmetry was going around the vertex. Here we started at the vertex, and we're just doing the right-hand side of the parabola. So where does my axis of symmetry go? My axis of symmetry goes right here. That's your mirror, okay? And if you can figure that out, you just go to the other side of the mirror and plot those 2 points the same distance away. And here's your parabola. So that's much, much faster because we have 3 less points to deal with. We are only doing with 3, and it's always going to be the 3 on the right-hand side of the parabola. You put your axis of symmetry down the first coordinate from the first coordinate in the table, and then you draw on the left-hand side of that axis of symmetry the points at the exact same height and the exact same distance away. And that matches that equation. -2 means a reflected parabola, so it's upside down. 2 means that it's stretched. A little hard to see the stretch here because of my scale, folks. But the regular parabola, if I like kind of draw in what it would look like, it would do something like this. It would be stretched. It would be wider because the stretched of the blue one makes it narrower. Okay, but it is a little bit hard to see. However, our coordinates are correct, so we're trusting the math here. And then our vertex is at -3, -1, -3, -1. And we can see our vertex. So what I'd like to do next is I want to show you some examples of the homework questions you're going to encounter in your homework today, just so that you have some examples to go back to if you get stuck on something. And oftentimes the book doesn't ask things exactly the same as I do. Now that's somewhat to push you forward, right? To help you, to try to get you to think a little bit. Like, what do I know about this? Can I answer it in this new context? But because this is a brand new thing and we're putting everything together today, I thought maybe it'd be better if we actually did a few of these together. So for each parabola, identify the coordinates of the vertex and determine whether A is positive or negative. So one thing I used to like to do when I was learning math is I always used to like to write the equations that I was dealing with for a little while every time I was doing a question, because it would help me remember the formula eventually. Okay, so I'm just going to write the formula for the vertex form of a parabola right here. And this helps me also understand what do they mean by the A here. Okay, so they're talking about the A in the equation. So the first thing we're going to do is identify the coordinates of the vertex. Well, for this parabola, that would be right here. What is that coordinate? 1, 2, 3, 4, 5, and going up by 1. So for A, my vertex is 5, 1. Okay. Determine whether A is positive or negative. Well, is it a smile shape or a frown shape? So because it's a smile shape, we know that A is positive. And that's all they're asking you to do for that question. So it's a nice little warm-up question just to get you starting to think about things. Now, I should have maybe shown you a picture of a negative parabola, but I can just, like, this would be one where A would be negative. Okay? I'm not going to do the second one because it's pretty much the exact same thing as the first one. So for this question, it says, for each quadratic relation, identify the coordinates of the vertex. Determine if the parabola opens upwards or downwards. Now, what does that mean? That's just another way of saying smile or frown. Opening upwards looks like this. Opening downwards looks like this. Okay? So that's just another way of saying, is it a smile or a frown? And then it says, determine if the parabola is vertically stretched or vertically compressed. It then also says to sketch the graph. So for A, identify the coordinates of the vertex. Well, here's our equation for A. Where do we look to see the coordinates of the vertex? Well, we look at the H value and we look at the K value. You have to remember that the H value is always the opposite of the sign that's in the bracket. So this will be a +3, and the K value is the same, so that'll be a 12. Determine if the parabola opens upwards or downwards. That is controlled by the A value. A is positive, therefore it's a smile, which would be opens up. Okay? And then it says determine if the parabola is vertically stretched or vertically compressed. So the A value is a number greater than 1. Forgetting about its sign, just looking at the number. In this case, it doesn't matter because it's positive anyway. If A is greater than 1, that means we have a stretch. Oops, that's supposed to be a C. Let's look at B now. Now for B, what would be the vertex? Oh, by the way, I'm not going to sketch the graph, all right? If you know all of the stuff that we've seen before, actually, I think I might sketch this one for you because it's one of the first times you're going to see a decimal value for your A, so I think I will do this one, but I'm not going to sketch this one over here, okay? So the vertex is based on your H and K. The H is the H in the bracket is -10. The H in our vertex is going to be +10. The K value is -1. That doesn't change signs. It is a -1. Our A value in this case is negative because it's -0.5. That means we have a frown or opens down. Parabola. And the value of A is between 0 and 1. Because it's 0.5. Forget about the sign, because we've already dealt with the sign. The value of A is 0.5. That means it's between 0 and 1, which means it's a compression. Okay, so what would I do to sketch that parabola? So I'm going to need my table of values. Both of them. Okay, so we do have both an X transformation and some Y transformation, so I'm going to need to leave some room for my X transformation. So I'm going to write 0, 1, and 2. Okay, we're just going to be using the right-hand side of our parabola. Okay, so 0, 1, and 2. That's 0, 1, and 4 for the Y values. Now, what am I going to do to all of the X values? I'm going to do what's in the vertex, which is +10. Now, what am I going to do to the Y values? The Y values have both a -0.5 and a -1. So both of those things have to be done to the Y values. Now, the -0.5 is a multiplication, So I'm multiplying by negative 0.5 and then subtracting 1. Multiplying by negative 0.5, subtracting 1. Same thing for the 4. And you may need a calculator to do the y values this time. Okay, so our x values are going to be 10, 11, and 12. Our y values are going to be 0 times negative 0.5, which is just 0. 0 minus 1 is negative 1. 1 times negative 0.5 is just negative 0.5. Negative 0.5 minus 1 is negative 1.5. And 4 times negative 0.5 is negative 2. Negative 2 minus 1 is negative 3. So if I was to sketch this parabola, now you can see my x values are fairly large, right? 10, 11, and 12. So I've got to go a little bit further along my x-axis. Sorry, I wanted to use this one. Nope. Sorry again. This one. And I also have negative numbers, so I'm going to be a little bit below. I'm going to be more below than above, so I'm just going to do this. Okay. So let's put our scale now. If you had graph paper or Desmos, that would be a lot easier. But let's say that 5 is here, 10 is here for my x value of 10. That means 11 and 12 are going to be here, right? We also have to go negative 1, negative 2, negative 3. Okay, I'm actually going to write my 10 a little bit smaller than that. Okay, so let's plot our points. I'm going to use blue for that. So 10 and negative 1 would be approximately here. 11 and negative 1.5 would be approximately here. 12 and negative 3 would be approximately here. Now, where is my axis of symmetry? The axis of symmetry is always through the first point. Okay, so now I'm going to mirror the other 2 points on this side at the same distance. So I'm going to have a point here, and I'm going to have a point here, and that's going to be my parabola. All right. So there may be times where you're going to have to do these by hand instead of with technology, and using the 2 tables here, I believe, is really the easiest way to do it. Also remembering that your axis of symmetry goes through your first point and then just mirroring the other points on the other side of that. Okay, let's keep going. So here it says graph each quadratic relation by plotting the vertex and 2 other points, then draw a smooth curve through those points. So what are they asking you to do here? They're just asking you to do those 2 tables like I just showed you again. So let's say we do B here. We're going to do B. I just want to show you another example with a decimal value for A. So 0, 1, 2. Oh, and I forgot to leave some room. And then 0, 1, 4. And now let's look at what's happening to our x values. Well, our x value is at plus 4. Now notice they didn't ask you what the coordinate of the vertex is, but they did say by plotting the vertex first. So what would our vertex be? Our vertex is going to be the opposite sign of the plus 4, so minus 4, and the exact same sign and number for the k, which is minus 2. Okay, so that's our vertex. Now that actually also tells us what to at least do the x value. So we're going to subtract 4 to all of our x values. And our y values are going to be based on the minus 0.25 and the minus 2. So we're going to multiply by negative 0.25 because it is multiplying the bracket. The main operation is a multiplication between the 0.25 and the bracket. And we're going to subtract 2. Oops. So what are our x values? We've got negative 4, negative 3, and negative 2. What are our y values? 0 times anything is 0. Minus 2 is minus 2. Now 1 times negative 0.25 is negative 0.25 minus 2 would be negative 2.25. Now if you can't do that in your head, please use a calculator to do that calculation. 4 times negative 0.25 is going to be, well, that's a quarter, right? 0.25 is a quarter, so 4 quarters is $1, but this is a negative dollar, so it's negative 1 minus 2, which would be negative 3. And then you would plot this again. So this time we need some, just going to check something here. Okay, so this time we need more room along the left-hand side because we've got negative 4, negative 3, negative 2. So I need more room over here because that's where my points are going to be. I'm figuring that out by looking at the x values and the y values. The y values are negative, which means down here somewhere. The x values are negative, which means over here as well. So negative 1, negative 2, negative 3, negative 4, negative 1, negative 2, negative 3. So negative 4, negative 2, negative 4, negative 2 would be here. Negative 3, negative 2.25, negative 3, negative 2.25 would be about here. And negative 2, negative 3 would be about here. I'm going to draw my axis of symmetry. Now I'm using this fancy little dotted line here, but you can just use a dotted line on paper. Remember, it goes through the vertex. And that actually means, and this is I think what some students mess up, is they think, oh, I don't have enough room on this side of the graph, so it must be this way. No. It's always to the left, the points that you're mirroring. So that just means you didn't go far enough on that side, okay? So I'm going to mirror that point there, mirror that point there. Try to draw my parabola as nicely as I can through those points, and we are done. Let's look at this last question. Identify the coordinates of the vertex of each parabola, then write an equation for the relation in the form y is equal to a times x minus h squared plus k. So I think this is the last question, if I'm not mistaken. It is. It's also a slightly more algebraic question. I did show how to find a knowing the parabola before, and I'm going to show it again. It's a little bit longer this time, but it's basically the same thing. So, and we're going to do B. Actually, let's do C. If we do C, which is one of the harder ones, you should be able to do any of the other ones. Okay? So let's first start by finding our vertex. So what is the vertex for C? Well, the vertex is right here. That is negative 4 and positive 8. Now, I'm going to do something here that might confuse you, and you're going to say, sir, why are you putting a negative 4 in the vertex? Shouldn't it be the opposite sign? The answer is no, not when you're going from the graph to the vertex, because it's the equation sign that's opposite. The graph's sign matches the vertex sign. That's how you plot the vertex, okay? So where does that negative 4 change signs? Well, it changed signs when we put it into the equation. Okay, and it's minus h plus k, right? Now, this might be a little bit hard to understand, but if I do minus negative 4, that's going to give me a plus 4. Most of my students usually just want to remember that it's the opposite sign in the equation, okay? So the vertex x coordinate will be the same sign as the vertex coordinate on the graph. It's in the equation that it changes signs. So that can be a little bit confusing. Our plus k is based on our 8. And one thing that a lot of students will also forget is to put the square here. All right? So if you don't mind me going way back to the beginning, we're using this general equation here, right? So we're replacing our h value, our k value, and the square has to be there as well to make sure that it's the right format. How do we find a? Well, I showed this the other day. We have to use algebra to find a, okay? That means I have to substitute a point in for x and y so that I can isolate a. So we want to sub in an x and y to isolate a. All right? And as you can see, that's why on all three of these graphs, they've actually highlighted other points besides the vertex. It's because they knew that you were going to need an extra point to be able to sub in here, and they're just highlighting what that point, choices for that point, because there's actually two choices here. So for letter C, let's use this point right here. So what is the coordinate of that point right there? Well, it's 1, 2, 3 backwards, so that's -3 and 2. So we're going to sub in -3 and 2 in for the x and y of the equation. Now, I can't state this enough, folks. The x is first in the coordinate, but the y is first in the equation. So please make sure to put the right number in the right place. So the 2 goes first. Then we're going to replace x by -3. The rest of the equation stays exactly the same. And now you can see that the only variable left is our a value. So we need to get our a value all by itself. Now, how do we do that? Well, when you're isolating a variable, you always work your way outside in to the variable. So the first thing we're going to move is this +8 over here. So we're using regular algebra rules now. When you move something over to the other side of the equation, you use the opposite operation. So the opposite operation of a +8 is a -8. So we're going to subtract 8 on that side. Now, to speed things along a little bit, folks, we're going to have to group the -3 plus 4 because they're in a bracket right next to each other, so they can group up. So what is -3 plus 4? -3 plus 4 is 1. Okay, so we've got 2 minus 8, which is -6, equals a times 1 squared. Now what's 1 squared? 1 squared is just 1. Now this makes this question pretty easy to do because all we have to do now is get rid of that 1. Well, 1a is already pretty much getting rid of itself. But what happens if that number isn't a 1? Well, the proper technique is to divide both sides by the number that's beside the a at this point. It just happens that with a being multiplied by 1, that we end up with a is equal to -6. So does that seem to make sense that a would be equal to -6? And we'll put it in the formula in a second. But take a look at this graph. Doesn't this graph, isn't this graph a frown shape? So our a value should be negative. And doesn't it look a lot more narrow than either of those two graphs? Okay, so narrow graphs for parabolas means stretched out parabolas, which means numbers that are greater than 1 for a. 6 is greater than 1. Okay, so what is our final equation? Y is equal to -6 times, if we go back up here and look, it was x plus 4 squared. So our final equation has to go back to having the x and the y in it, because that's how all equations look when we're done. Okay, and then our plus 8 from our vertex right here. And that is our final equation. So to recap this question a little bit, you have to sub in the vertex numbers into your h and k, making sure that your vertex h value is the opposite sign of what it is on the graph. Okay. Then you have to substitute in another x and y point for x and y in the equation, right here and here, which I did here. Then you have to use a little bit of algebra, which is usually bringing this number over to the other side, grouping those two numbers together in the bracket and squaring them, and then dividing by whatever that number is to get your final answer for A. Once you've got all that, you can substitute all of the numbers back into the equation, making sure that the x and y are back, because your final equation has to have x and y in it again. And that is your equation for that parabola. So I've now shown you an example of every different type of question, mostly every different type of question in your homework. So, and that is the end of today's lesson. So hopefully you'll be able to work through some of that homework, and if you need to, refer back to the video, and I'll post the note as well. And that way, hopefully you'll be able to get through it mostly on your own. If you need any help, please let me know. Have a great day, everyone.